There is a place on Earth where lightning has been striking the same spot for 500 years. Not occasionally, not seasonally, every single night. 1.6 million strikes per year. The most electrically active place in the recorded history of this planet. And it has been doing this since before Shakespeare wrote his first play. And here's the thing that should bother you. Nobody is seriously trying to understand it. In an era where we have mapped the ocean floor, landed precision rovers on Mars, and built algorithms that can predict your next purchase before you even feel the urge, the most concentrated natural electrical phenomenon on Earth has generated exactly 0 industrial-scale research programs dedicated to unlocking it. 0. That is not an oversight. That is a choice. Let's establish the facts, because the facts, standing alone, are already extraordinary. The lightning, named after the river that feeds into Lake Maracaibo in northwestern Venezuela, called House of Thunder in the language of the indigenous Bari people, is not a storm. It is a permanent atmospheric condition, 140 to 160 storm nights per year. Not days, nights. This phenomenon operates after dark, like it punched a clock and chose the night shift. Up to 280 lightning flashes per hour at peak intensity. 250 strikes per square kilometer annually. The highest lightning density ever recorded anywhere on this planet. 9 hours. The duration a single storm can run without interruption. 9 hours of continuous, unrelenting electrical discharge, visible from 400 kilometers away. For centuries, sailors navigating the Caribbean used it as a lighthouse. Free, automatic, inexhaustible. They called it the Beacon of Maracaibo. And then NASA ran the numbers. Using satellite data collected between 1997 and 2015, NASA calculated that the energy discharged during just 10 minutes of this storm could illuminate the entire continent of South America. 10 minutes, not 10 hours, not 10 days. 10 minutes. A single lightning bolt carries approximately 1 billion joules of energy, enough to power the average household for a month and a half. There are 1.6 million of those bolts per year at Lake Maracaibo. Conservatively, 1.6 million bolts multiplied by 278 kilowatt hours each. That is approximately 444 billion kilowatt hours of theoretical energy annually. Germany's total electricity consumption in 2023 was around 500 billion kilowatt hours. One of the largest industrial economies on Earth, automatically generated every year by weather, above a lake in a country where millions of people do not have consistent access to electricity. I need you to sit with that. Because once that thought gets in your head, it just stays there, looking at you, waiting. Before the science, and we will get there, there is history. Because this storm has been operating long enough to appear in battles, in logbooks, in the dispatches of explorers who had no framework to explain what they were witnessing. July 24th, 1823. The Battle of Lake Maracaibo, the final major naval engagement of the Venezuelan War of Independence. Simón Bolívar's fleet needed to move at night. The maneuver required darkness and surprise. What they got instead was a sky ablaze with hundreds of lightning flashes per hour. The storm, indifferent to the war below, doing exactly what it had done for centuries. Bolívar's ships navigated by it. The Spanish forces were caught unprepared. Venezuela secured its independence. A storm that no one fully understands helped liberate a nation. 1595. Sir Francis Drake attempted a night raid on Maracaibo. The lightning betrayed his fleet. The raid collapsed. 1678. The French corsair Jean-Baptiste Ducasse. Same lake, same lightning, same failure. This storm repelled invaders for 4 consecutive centuries before anyone thought to ask what it actually was. And the answer, it turns out, is still incomplete. The official explanation involves several converging factors: trade winds carrying moisture from the Atlantic, the Andes Mountains surrounding the lake on 3 sides, trapping that moisture, the warm surface of Lake Maracaibo acting as a continuous heat engine. These systems collide above the southern shore and generate the ideal atmospheric conditions for perpetual thunderstorm formation. That explanation is probably partially correct. The problem is that it does not explain everything. Other regions on Earth share similar topographical and climatic conditions. None of them produce anything remotely comparable. Why does the storm predominantly ignite at night and not during the day? Why did it go completely silent for 3 months in 2010, the first documented interruption in recorded history, and then resume without explanation, exactly as before? Nobody knows. There is a competing theory. Between 1997 and 2000, 4 separate studies proposed that natural gas, rising from the surrounding swamps and from the colossal oil deposits beneath the lake, could be amplifying the electrical activity. Natural gas ionizes air. Ionized air is a more efficient conductor of electricity. Lake Maracaibo sits directly above one of the largest petroleum reserves in the Western Hemisphere. Underneath the most electrically volatile place on Earth, the natural gas theory was never conclusively proven. It was also never conclusively disproven, because no one funded the research to settle it. Here's where we have to be precise, because precision is the difference between a legitimate question and a conspiracy theory, and this is a legitimate question. Can we currently harvest lightning at industrial scale? No. The technology does not yet exist to capture and store electrical discharge efficiently. A direct capture system generates approximately 1 kilowatt-hour per year on average, according to published research. The energy in each bolt dissipates in microseconds. The engineering problem is real and unsolved. But here is what the researchers who study lightning energy consistently say. The bottleneck is not the lightning. The bottleneck is the capture, and capture technology advances when people invest in researching it. Venezuela is a country where millions of people live without consistent access to electricity. It holds some of the largest documented petroleum reserves on this planet. And within its own borders, it hosts the most concentrated natural electrical phenomenon in the history of recorded science. The international scientific community's response to this convergence has been a handful of papers. A University of Zulia study on atmospheric variables, a 2016 forecasting model, satellite data from NASA collected between 2 unrelated missions, a handful of papers. Germany has not sent a research team. Australia has not sent a research team. The UK Met Office, with 1,700 employees and a budget that tracks every storm system on Earth in real time, has this storm on its maps as a recurring event. Nobody went. I'm not telling you what to conclude from that. I'm just telling you what the record shows. In 1898, H.G. Wells published a novel about an alien invasion of Earth. The Martians did not arrive in spacecraft. They descended through focused electrical strikes, machines that hit the same coordinates repeatedly with lethal precision. Wells wrote that 40 years before, Orson Welles turned it into the most famous radio broadcast in history. He wrote it 3 centuries after Francis Drake's fleet was exposed by a storm that had already been striking the same coordinates for generations. The most alien thing on this planet, the thing that most resembles the science fiction we invented to imagine what we cannot explain, has been here the entire time, above a lake in Venezuela, striking the same spot every night. And the question that nobody in any serious institution is asking is not whether it is beautiful. The question is what it is worth, and to whom to leave it unexamined.